Hi there. I basically, I think Dave asked me to give a talk here some time back, and I thought, and it was around then I started working with some numbers for a change, which made a big change after working with loads of text and stuff for years. So I started working with some numbers and discovered, well, as usual, you go through all the tools you can find and try and find out which ones fit with the way you work and which ones are nice to work with. Can everyone hear? Anyone who can't hear me? I've got a mic here. Oh.
So that one is just
hello?
There you go.
Oh, I've got two. You should be able to hear me twice. Anyway, so I started working with some numbers, and numbers are quite fun actually, but and numbers in JavaScript are quite fun, and so I went through all the libraries and decided that most of them were really horrible, and I used a lot of tools, and I tried a lot of things out, and I tried to make things work in Flash, and I tried to make things work in IE6, and I tried lots of stuff, and eventually I decided that D3 was absolutely the nicest library for working with data that there was in JavaScript, and I should tell everyone about it, and so here I am telling you about it. Just a few credits. I didn't write it. It's by Mike Bostock, who's a very nice guy and very helpful on the mailing list. It's all open source. It's all BSD licensed. It's all free to use. No caveats. Thanks to everyone on the mailing list. The D3 mailing list is really nice, really friendly. When you're getting started and you're stuck, someone will help you and suggest a way of doing it. I used lots of demos in this talk to make it more pretty, and I didn't write them, so credit to everyone who did. And this presentation was from the HTML5 rocks, and it's really nice doing presentations in HTML5. I never use anything else. So hopefully this will take about half an hour or so. It shouldn't be too long. Interrupt me. We're going to do code. So interrupt me if you've got any questions while we're doing it, because it's probably better than asking at the end. But there should be some time for questions at the end. So why is it nice? What's nice about it? Why use it? When I started, the first thing I tried to do was use graphing libraries. And what they generally were was you give them a big configuration object that contains a large list of parameters, and it comes out with a graph, and it doesn't quite look how you want, because there isn't something to change one aspect of the graph you're trying to draw or something like that, and you go, the client wants it to be, this bit to be, have a pink stripe, and I can't make a pink stripe because there's no pink stripe option in my JSON object I'm passing into this library. D3 is about code, not configuration. There is no configuration anywhere, which means it's a little bit slow to get started, but as I'll show you, it's really pretty easy. And there's a great community. It's code, it has a community, not like some Google Graph library or something else which doesn't have a community. Also, you can draw nice, pretty pictures. We'll see more later. So what I'm going to do is really just walk you through a kind of simple code example. I'll show you all the code, and it'll work, and it'll run in the presentation. You're going to have to learn a little SVG if you don't know any, but SVG, D3 makes SVG easy, whereas if you look at the XML format for SVG, it looks nasty. But actually, it's just something that you run in the browser. It's part of the DOM, and it makes shapes, and it's nice. And you get used to it, and D3 will make it much nicer. XML is a horrible format. So we're going to do a simple graph. We're taking data from a company called Time Metric, who you can't read at all because their logo is white on white, who are based in London, and they format data very nicely to make it easier to use. It's actually data from the Department of Transport, but their data is horrible to use because it's all in zip files, and it's horrible. And we have a little bit of boilerplate here. D3 is a micro framework. It comes in little modules that do little bits. It actually covers pretty much all the functionality you want. So here we have an Ajax call. So D3 has a little Ajax library. you generally can get away. I mean, for something like everything I've done in this presentation, I just use D3. I don't use another JavaScript library because it's got enough to do the basic stuff you need to do with graphs. You can use it with other stuff easily too. So we get our text file from here, and we're going to draw our graph. It's a CSV. D3 contains a CSV library, which is really useful because lots of data you find on the web's in CSV format, because it's the kind of default format for data. JSON's obviously easier to work with, but not many people provide data off the shelf in JSON. So we get our CSV, we parse it here. So we parse it. The data for this is simply a date and a value. It's the easiest thing. It's an ISO date, except the people at Time Metric mysteriously missed the Z that's compulsory off the end of the ISO time format off the end, which every browser doesn't care about except for iOS, which refuses to pass an ISO date without the Z at the end. So if there's anyone from Time Metric, please could you fix this? Parsing is an annoying thing, again, about working with data, because everything you get in data comes as text, and you then, first thing you have to do is parse it. So there's always a bit of that. And then we're just going to define a size for our graph. We're going to select our bit of HTML that we had in, we should have had in the previous slide. Sorry.
You really like each other.
And oops, sorry. Sorry, I'm leaning on the keyboard now. SVG is the basic SVG container that's a rectangle that you draw your SVG stuff in, which has a width and height. And then we're going to stick an SVG G element. A G is just a grouping of SVG elements. It doesn't really correspond to anything HTML, but it's just a useful thing for sticking classes on in your hierarchy in your DOM. And in this case, we've got a big box, which is our graph, and then we've got a little box inside, which is the bit we're going to display our data in, which we're shifting across a little bit inside our graph. It will become clear in a minute when we draw it. Next thing we're going to do is look at our data and see the range of dates and the range of values in it, because we want our data to fit in what we're drawing. So extent simply returns a minimum and maximum of an array. It's just a useful D3 function. Again, D3 has all these useful functions that are helpful for the domain of drawing stuff. And then D3 has scales, which are basically devices that take your input data scale, which is from 1980 to 2010, your dates, and stick it in your pixel scale for the bit you want to draw. So we've got a time scale, which takes our dates, which are our x's, and sticks it in the range we're drawing, which we defined before, and the same a linear scale for all our values that we're going to draw that way. And these are the functions that apply our x scale to the date in our data and our y scale to the y in the data. We're nearly there, and then we're just going to draw the simplest possible thing. We're just going to draw some little circles. So we're going to group our circles into a class of points, because these are the points in our graph. So just this grouping is just for CSS purposes. We're going to draw circles. We're going to sorry, this is slightly this will become more clear later on, I think. But we're going to select all the circles that are under our class of points, which at the moment there aren't any of, because we haven't drawn anything yet. So it's a kind of useless selector. We could just get rid of this. We're going to apply our data. Now this is a D3. Basically, D3 works with arrays and applies data to them, and then lets you do things with your data. So it takes an array of DOM elements, which is nothing in. It applies this data to them, and then this enter function says, give me all the new things which have got data but didn't exist in the DOM because I want to do something with them. So that returns the array of elements that didn't have anything in, which correspond to your data points. And for each of these, you want to append a circle to the DOM, which has a radius of 5, and a position, which is a function of the data value, and an x and y position, a function of the data value, and a title, which is a name, which is probably not entirely clear. But let's just add some CSS. The nice thing about SVG is it's just DOM elements, just CSS. So we've got a class of points, and we've got circles in those points. And we have CSS has strokes, which are the lines that go around objects, and fills, which are the bits inside them. So if we draw it, we've got a bunch of circles with insides and outsides corresponding to our data values. And if you just go and look, you can how do you right click on them? You can just inspect these in Firebug just like anything else, and you can see that what our elements are. Here's our circles with a radius of 5 and their positions, and you can see the CSS that's set on all of them. So it's the great thing about SVG is it's really nice to debug. It's just like everything else. You just look at it and you can see what objects you've got and what the titles show up as when you hover over them as the names there. It's just like debugging anything else, and it's really really straightforward. Is that reasonably clear? If you've so just carry on. Then let's add some axes. So D3 comes with some helpers for drawing axes, which make it easier than actually drawing all the numbers and the lines yourself. So axes, you tell them what the scale is, whether they're left or right, and you can give them ticks, and then you can just append them where you like. Similarly, and then again, just CSS for we want them grey, 1 pixel, and we get axes, which correspond to our data points. So it's so we're kind of getting there. And let's draw a line. Now, lines in SVG are a little bit, and paths are a little bit weird. Instead of having separate DOM elements for each part of a shape, you have a shape, and then you have one attribute that basically describes move, line, 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 and then close it at the end. So that'll define a square, which is take a bit of getting used to how to work with them. But again, D3 has a useful class which will draw a line given the data and the functions, the scales that you want to map from. So this will draw a line based on these functions we defined, which map our data on. And again, we can so this defines a line, and this one we're just closing our line at the end to draw. Because our line looks like that, we just want to draw a box around it so we can fill it in underneath. It helps sometimes just have a bit of graph paper and draw these things out in advance. And we can add CSS gradient for our area. CSS gradient syntax is a bit weird, again, until you get used to it. So we're filling with this fade that's defined on this in this bit of DOM there, which is a kind of weird way. You can't define a gradient purely in CSS, which is slightly odd. And then we get our graph with our line and filled in. So it's already looking kind of acceptable, with really not much code. That's really quite straightforward. Then we can cheer it up a bit by adding some transitions. we'll fade in our line. So instead of starting it, we'll start it with a 0 opacity, or almost 0 opacity. And after 2 seconds, we'll change the opacity to 1 over 3 seconds. And for our circles, we'll start them with a 0 radius, so they start at a point, and then we'll change the radius to 5 over a duration that's a function of the data itself. So we'll define a scale so that the ones at the beginning of the period fade in 1 second, and the ones at the end with the dates at the end take 6 seconds. So we'll get a little fade in like that, and then we'll fade in the color at the end. So really easy to do things like that. Just make it a little bit nicer. And then really coming to the end of the coding bit here, last thing we'll do is just do some dynamic updates to our graphs, because we like to AJAX in new data. So what we'll do is we'll add a new item to our data. We'll recalculate all our scales to make sure that the data now fits. We'll select our points again and apply our new data to them. And then we'll do a transition to the new position here, so that they'll all move to their new position on the new scale. So we'll do that, and then here we'll take all the points that have been added, and we'll increase their radius to 5. So they'll start as a point and grow out like our original ones did. And we'll update our axes to the new scale as well with a little transition, because axes are built-in objects that have transitions too. So how are we getting on? We haven't quite done everything, but we added our new points. We haven't changed the line and the fill yet, but so far our axis is updating and our new points are coming in, so we're nearly there. For the line and fill, for the line, it's fairly straightforward. We just update the line with our new functions and update that. If we do the same with the path, we'll see that doesn't quite work, but it nearly works. So if you look, the path isn't really updating quite right, because it doesn't actually quite know how to interpolate it, because it looks at the points we had and the new points that we've got. But because we had the extra bit in the path that closed the path is the same line, and then we join it round there, and it doesn't quite know how to interpolate that. So we just need to make a little custom interpolation that basically takes this closing bit off and then sticks it back on. And also, we'll add another thing that if the scale gets too long, we'll just subdivide it every 10 years instead of every 5 years, so that if we had lots of points, we should be fine. So that's all working nicely for our new points, and we can add loads more points. And our scale goes to 10 years eventually when in the dangerous days of the future when cycle accidents are very high. Well, I think I biased my random numbers to go upwards without realizing this isn't real data in the future, hopefully. So that's it's really straightforward. This is the kind of, this is basically how you can do dynamically updating pretty looking graphs with transitions, and it's really not very hard. And it's, there's no black magic parameters saying background equals pink and that you have to change and things like that. You just really put objects where you want them, and you apply data to them, and you update the data, and they move. And the defaults mostly just work, and it's just really nice. you apply data and you set any property of any object, like color or position or size, and then you have your transitions, and it's just really nice to work with. You do have to sit down in advance and kind of work out how it's going to work a bit. It helps a bit. But it's got everything you really need to do that, and you'll see a lot of these in the demos that I'm going to show you next. So it's got a whole bunch of really helpful stuff to do the kinds of things you might want to do. So here's some things you can do. These are all stuff I sort of picked up off the web. This is UK one, US one, showing where they parse the Twitter stream and look for events related to the US elections. And so you can see it's got a dynamic scale, and then you can select things and see what the event is, see what's going on, get the tweets. Again, so all done using D3. It's quite nice. This is a nice little example of just a little explanation of how different shuffling algorithms work. There's a better explanation on the page with the code for the different algorithms, but it's an explanation about efficiency of shuffling algorithms. Just a really nice, simple way of explaining stuff that a picture works much better. That this is an in-place shuffle, and this is this takes items out, and this takes items out and moves them down. So you can kind of see visually how the different algorithms work. Pictures are really good for explaining things. This is just a bit of fun. If you basically move the mouse over the circles, then eventually...
This is all SVG, right?
Yes. Yeah, I'll talk about non-SVG stuff in a minute. Eventually you get to see the koala.
I was expecting kittens.
Hours of fun. This just shows what you can do with maps. Again, just SVG and maps. All the data for the maps on these demos it ships with D3, so there's US maps and world maps in SVG already, so you don't have to hunt out all the mapping bits and pieces, which is a real pain if you are trying to do them yourself, as I discovered once for a job a while back, trying to redraw the borders of Sudan when it's split in two. You think countries don't go out of date, but it's amazing. This is UK university stats, which you can look at different breakdowns of the data, and it gives you lots of information about male and female engineering and how that's changed over different periods of time. This one is just again, a simple diagram. I really think that simple diagrams about how sine waves work are just useful things, and if you're doing EPUBs or something like that, you should think about putting diagrams in them, because it's just much nicer. It's quite hypnotic as well. This is shows you how you can basically draw graphs and get them to lay themselves out so that they basically cluster nicely. All the clustering algorithms for this, again, ship with D3 and one of the extension libraries, so that if you want to do things like this. This is based on the characters in Les Miserables, and if you hover over them, it tells you who they are and their relations in the play. Jason Davis isn't here, is he? He's the only person I think from London who's done one of these demos. But this is again, just another fun one of showing what you can do with flocking algorithms and areas, which I thought looks quite nice. Again, with all these demos, if you go, this is presentation at lws.node3.org, and you can just look at the code. It's all there. Most of it's, apart from the couple which I iframed, it's all in line, so you can just right-click and inspect and have a look at the code. So, now talking about accessibility and compatibility, and the question you're inevitably going to ask is about, well, SVG. So SVG first. Let's deal with the difficult thing. SVG works on Firefox, Chrome, Opera, IE9, and Safari. Works very well across all of those. I've run this presentation through all of them, and there's one little bug in IE9, but I think it's my fault. But I only noticed just before. But basically, the SVG spec is huge, and the coverage is not actually 100%. But most of the stuff you would ever want to use is well supported across all those browsers. Same with mobile browsers, including Opera Mini and Opera Mobile. I was quite surprised both run SVG fine, and Android after Android 2, but which is unfortunately not the Android most people have. And IE Mobile 9's lovely. I run all the D3 demos as soon as someone saw one of someone's nice Nokia Windows phone. Everything runs fine. So about 68% of users probably, but not IE8 or Android 2 or Kindle WebOS or WebOS or screen reader. So not everywhere. Is that a question?
Isn't there a plugin for going back to?
Yeah, I'll come to that in a minute. I think it's on the slide, yes. So your solutions are Chrome Frame, great if people have installed it. Rebuilding everything in Flash, which is pointless because you have to do it twice. SVG Web should do SVG in Flash, and some people have got it to work with D3. It's not officially supported, and there's a ticket which is linked to there if you want to click on this and have a look about people having got it to work. I have to say I haven't actually tried it. The problem is SVG is a big spec, and you're doing DOM manipulation, and you'd have to test it. But it's potentially doable. Surprisingly few people seem to try, which is interesting. VML is a really, really, really horrible thing that Microsoft implemented in 1998 and hasn't updated since. It's what Raphael uses in IE6 to 8. In theory, it's very like SVG. It was a precursor. A lot of the DOM elements are the same. The problem is it doesn't really work with DOM manipulation at all. You can't really update anything, it seems. I tried using it, and it was with directly with D3, and it just bizarrely just doesn't work. Microsoft don't really support it. You could try, but you suddenly remember how awful browsers were. It's not even compatible across different versions of old IE either. They changed it in IE7, and it really is quite horrible. You can fallback static images if people don't have SVG. That's actually quite a nice solution for things that aren't going to be dynamically updated. If you're just doing a chart for a newspaper article and you want a non-SVG fallback, just take a picture of it and stick it on. It's hard to automate because rendering SVG server-side it's doable but messy, and like rendering anything server-side. So if you have dynamically updated stuff, you're going to have to spend some time on a workflow for that. But It's doable. It helps if you don't use CSS in your SVG, because a lot of things like a lot of the SVG renderers for client side are standalone things like Inkscape, which are great SVG renderers, but they don't understand CSS because they're not browsers. But it's actually entirely feasible to not use CSS and just assign all the properties directly to everything. I like using the CSS with SVG because it's actually just nice. But if you want to, you can actually avoid it. Use a table. This is a good solution. Tables are pretty. If someone sees this, they'll never know that they're missing a lovely infographic. Seriously, they won't. They'll just think that this is it. The prettier you make the table, the better. Great for mobile, where none of the Flash or VML solutions are going to work anyway. So people with Android phones, say, or people with Kindles, they'll be entirely happy and they'll never know there was anything else. And it has all the data in it. It's great, and you can progressively enhance from the tables, read the data out, and use that for your graphic. Works for a screen reader. Really, I actually think that's a good solution for a lot of purposes. You can draw some stuff in HTML using D3 if you want. You can draw sideways bar charts really easily because they're just divs with lengths. Here's the code for that. Works for some things. Simple graph. You can animate them. Again, it's a good solution for some things. Depends what you what kind of graphic it is. I mean, often that might be sufficient for people with crappy browsers. It might be, if they're on mobile, a simple graph, simple table. I think you should choose depending on the situation. You shouldn't just assume you have to replicate everything exactly for everything. I mean, it's we're grown up now. So yeah, think what all the alternatives are. Don't just try and replicate it. Here's some more bonus demos. Here's all the transitions. It's basically an exercise in all the transitions, so you can see how you can transition things. Again, this is all using the standard, all the standard built-in chart types and stuff that are in there, so it's not actually very much code. And transitions are quite fun. Graphs shouldn't be static. Maybe they shouldn't be quite like this. And if that was a bit slow, oops, and that's it, a little bit faster. Should be. Oh no, it's not. Oh no, yeah, the Mac intercepted control click. Let's go on to the next one. This is a random diagram that I found somewhere that I thought was quite pretty. It is actually a random diagram. It's different every time you load it. Here's a globe, as well as here's the map of the world that comes built in, and again it comes with projections for all sorts of different geographic projections, and I just added some CSS hovers in just to show you can just add a CSS hover in like that because
North and South Sudan.
yes, that's South Sudan, that's North Sudan. I know the border well. And that's it, really. I think there's one more bonus. Any questions?